Hello, everyone. My name is Henri. I'm from a company, startup called streamr, based in Helsinki, Finland. And I just wanted to come up here and show you a little something, kind of a sneak peek into what we are doing. We are new in this space. It's just a prototype, so please be gentle with us. We are building kind of a usability and analytics layer on top of Ethereum in order to enable people to make easy and safe, real-time data-driven, scalable smart contracts. Now, what does that mean? Okay, easy and safe. We want anyone, even people without technical skills, to be able to define and deploy smart contracts in minutes. Real-time data-driven. We want data to be easily available and easily pluggable into smart contracts. Scalable. You know about the scalability problems of Ethereum, of course. We want to make it completely seamless to build systems that run both off-chain and on-chain, because currently it's needed. We want to be able to write smart contracts powered by, say, potentially millions of events per second coming from the IoT, the social media, the stock market, and so on. Okay, but it's easier to show than to tell you what it is. So let's build a fairly complex smart contract, data-driven smart contract system in 5 minutes. I'll just switch over to my browser. So, okay. So we employ a paradigm called visual programming, which means you can create smart contracts and analytics chains by combining blocks visually on a canvas. And you start with an empty one, like this one. So the first thing we need to put in there is data. And streamr is also a data marketplace. So you can go in there and buy and sell data streams or just use free ones. For example, you might be interested in building stock options and futures based on the Apple stock price. You maybe want to build a pay-by-use scheme for public transport. Maybe you're interested in Ethereum transactions to build a super cool block explorer or whatever. Maybe you want to build weather insurance for Paris. I'm not sure if you guys can see the text. It's rather small. So in this demo, we'll be using the public transport data. So I'll remove just these. Okay. So first, let's see what this data actually is. I'm going to add a module called the map. And I'll connect the vehicle ID to the ID input, as well as here are latitude and longitude fields. Just going to hit start, see what happens. Okay. So this is live data from my home city, Helsinki. And it shows the trams running around in the city. Now, in terms of use case, let's pretend we are the city of Helsinki, and we want to hire a tram operator to run trams in Helsinki. And we agree that we want to pay them not a fixed sum, but let's say we want to pay them by every meter traveled by the trams a certain amount. So that's our contract. And we want to enforce that contract on the blockchain. So let's keep adding some stuff here. I'm not going to kind of jump to the end of the chain. We begin with the data, we end with the payment, and then we'll add something in between. So I'm going to add a module called pay-by-use. Now, this is a module written in Solidity. We can inspect the code over here, make modifications if we want to. But especially I want to point out a function called update, which basically just reads the metric coming in as an argument and multiplies it by a unit price set before and tries to make a payout. So Let's set the recipient address. This would be the address of the tram operator. Then we specify that they get 100,000 Wei per unit reported. And let's initialize the contract with some ether. I'm going to hit deploy. So this will take some time because it needs to fall through the chain. So let's keep building while that's deploying. Now, how to call this contract? I'm going to add a module called etherium call, combine that with the contract that we built. I'm going to get a drop-down list of the functions available and select update. So this exposes the unit reporting functionality in there. There's an input called added units. So basically what we need to do is calculate from this raw data the distance traveled by the trams and report it over here. But okay, the trams are only sending their speed, heading, and location, and they're sending it quite often. This is a medium volume stream getting around 50 to 100 new events per second. So obviously we can't push all of that onto the blockchain. That would create like 50 to 100 transactions per second, which we don't want. So let's add some off-chain processing in between. Now, since we only get measurements of the position of the tram and not the distance traveled, let's add a module called for each. So for each tram, we want to calculate the distance traveled between two subsequent measurements. We could calculate it either from the GPS coordinates or take the speed and multiply it by the change in time to get the distance, so high school physics. We'll do the latter because the GPS is quite unreliable. So I'm employing a predefined template here just to save some time. I'm going to connect that to the speed. Now again, I'm getting distance increments out of here. So if I could now connect this to the smart contract running on the blockchain, but this would again flood the system, so something else is needed in between as well. So I'm going to add some summing logic in here. I predefined an abstraction called accumulator. So this is basically a summing operation. So it takes the distance increments coming out of here and keeps summing them until a threshold value is reached, and then it will commit that value out of this output called batch. And there's also an output called current, which gives the current value of the accumulation. So I'm going to enter 500 as the threshold. We definitely want to visualize that, so I'm adding a chart. Connect that to the current output. I'll also add a table to see what's coming out from the batch output over here. Okay, now we're ready to run again and see what happens. So we should get a chart, I'm going to zoom out a little bit, that keeps growing until it reaches around 500. Then it should drop back to 0 and start again. Okay, looks legit. And we also get a value that's a little bit over 500 from the batch output. So as you can see, now we're getting these aggregates every once in a while. I'm keeping it quite fast because of the demo, of course. So let's stop this. Now basically we can connect the batch to the unit input metric on the smart contract. And this would be fully functioning kind of micropayment system, but we want to validate that it works. Now a cool feature here is that any events created by calling the smart contract are also exposed as outputs over here. So basically I could create systems of smart contracts exchanging messages with each other and so on. So for now it'll be enough to just see that something is actually coming out of there. There's an output called paid amount as well as recipient balance and contract balance for convenience. So, okay, now fingers crossed, let's see what happens. So now every time the batch becomes full, an event is emitted from this output, goes here, goes on the blockchain, the update function gets called, and we should get the result over here once the block is mined. So let's see, at least there's one batch, full batch going on there. And now these are the longest seconds of my life. You can imagine what it feels like to be here. Okay, meanwhile, we can copy paste the address of the contract. Now this is running on the test net. We can go and see what's happening over there. We can see a couple of pending transactions, so basically this looks pretty good. Someone's hearing our call. Maybe they go through someday. Okay, something should be going. No. Okay, we got some events over here. So okay, now we can leave this running. Everything will work. Trams keep running. Everything's fine. People get home, and the tram operator gets paid. Now, the cool thing is, in this example, we're basically using Ethereum only for the payment part, plus honoring the price of the metric that we agreed with the tram operator. But now, in the future, we could be able to run a larger part of this on the EVM and on the chain as soon as the kind of transaction capacity of Ethereum increases, or there are new innovations like Golem or something that we can run on. So basically, you get in the future the exact same interface, but more of it can run on-chain and less of it needs to run off the chain. So we get better decentralization and better security, better reliability, and so on. Okay, that's basically it. If you like what you're seeing, please follow us on Twitter at streamr Inc. We also have a stand over there in the lobby. We'd love to get your feedback since we're new in the space. You can come and say, hey, you're doing a good thing. We know we're pretty early. You can come and say, hey, this is bullshit. We don't want a trusted third party to run these things or whatever. But we're getting there. We're coming from the streaming analytics space, and with hope that we have something we can give to this community. Yep. We make your streams come true. Thank you very much.